All right, so we're going to continue our discussion here in Mod 11 about inverses. And the main thing we want to remember about inverses is that for a function to have an inverse, it needs to be 1-to-1. And that would mean that the inverse would also be a function. So in this case, we're dealing with x cubed plus 1, which is a cubic polynomial. And we know the domain of polynomials is all real numbers. We know what the graph of this cubic polynomial is. It's a vertical snake type graph, but it's shifted up 1 unit. That's what that plus 1 is telling us. So this is the graph of my function. The domain, it spans to the left and right to forever, so we say all real numbers. And then the range of that, it goes up and down forever, is all real numbers. So when we think about the domain and range of the inverse, we don't even have to know what the inverse is. We can just take these two domains and ranges and switch them. And in this case, we're switching all real numbers with all real numbers, which doesn't really change anything. But there we have our domain and range. Okay? So if we want to find the inverse, the steps we'll always do to find the inverse function. So we're going to look at our function. F of x just means y. So we have y equals x cubed plus 1. In order to find the inverse, we switch x and y. So switching x and y, this is now the inverse relation. And in order to determine exactly what the inverse is, we just need to isolate that y value, get it by itself, which means I'm going to subtract 1 and then cube root both sides. So if I subtract 1 from both sides, now I have x minus 1 equals y cubed. And then to get rid of the inverse operation to get rid of that cube would be to cube root both sides of the equation. And I have written a plus there, but that shouldn't automatically change. It's going to be a minus 1 equals y. So using our inverse function notation, I'm going to say f inverse of x. My inverse function is the cube root of x minus 1, and all the x minus 1, that entire expression remains in the argument. So if we know anything about our cube root graphs, they're shaped like a snake, but instead of going up and down like the function we've already graphed on our plane, it goes horizontally left to right. And if we consider what we know about transformations, this is going to be shifted to the right 1 unit. So if I were to graph this, all of those 3 points that I plotted up above on my parent graph of the original function, we now have a inverse function that looks like this. Instead of being centered at the origin, it's centered 1 unit to the right. And the last thing we want to make sure we notice is that, this graph is a reflection over the identity, that line y equals x. So the function and its inverse are always going to be a reflection over the identity. So we have another example here in our notes. F of x equals x squared plus 3, and this is a parabola, x squared plus 3, but we've put this domain restriction, and I mentioned that in the previous video, that x has to be greater than or equal to 1. So it's only the right half of this parabola. And we know it's a regular quadratic shape, but that plus 3 is letting me know it's a parabola that's shifted up 3 units. So instead of having its vertex at the origin, 0, 0, it's shifted up 3 units. So the graph of the function we're looking at here, normally we would say, okay, well, it's this parabola opening up, but it's not the entire parabola. It's only where x is greater than or equal to 0. So it's the right half of the parabola. So we're only getting this piece of it. So this red graph here represents my function, f of x. The domain of f of x is that my x values are from 0 to positive infinity, and my range is that my y values are from 3 to positive infinity. So when I talk about finding the domain and range of the inverse functions, we're just going to switch those. So the domain of the inverse is that x is going to be from 3 to infinity, and the range of the inverse is that y is now going to be from 0 to infinity. All right, so in order to find the inverse, we'll go through our steps that we just did above. We treat f of x as though it is y. So we turn f of x into y. That's step 1. Step 2 is to switch or interchange your x and y. So now I have x equals y squared plus 3. And then the last thing we'll do would be to isolate the y. So in order to isolate the y, I'm going to have to subtract 3 and then square root both sides of the equation. So I end up with x minus 3 equals y squared. And then the square root of x minus 3 equals y. So my inverse function, f inverse x, is the square root of x minus 3. And so the graph of a square root function looks like the top half of a sideways parabola, but this minus 3, thinking about transformations, tells us it's shifted to the right 3 units. So my inverse graph looks like this. And you'll notice, and if you graph them on your calculator, again, they're a reflection over the identity function, y equals x. All right, continuing along. Again, we have another inverse. F of x equals the square root of x minus 1 plus 2 for all x that are less than or equal to 1. So graphing this. And again, you have your graphing calculator. You can always pull that up and look at it. No one's taking it away from you in this class. But we want to know what the graph is. And so I look at this and go, well, it's a square root graph. It's shifted up 2. The x is negative. So this is really like saying the square root of negative x plus 1 plus 2. So it's shifted up 2. It's reflected horizontally over the y-axis. That's what that negative in front of the x is doing. And then we're actually going to shift right 1 unit. And we talked about this a little bit in class with our transformations, but this extra negative in here in front of the x, the square root of negative x plus 1. Normally we would think, okay, well, the 1 is supposed to go left 1 unit, but the negative, it's like a double negative, so it actually does go right transformation-wise. So graphing this, the original function shifted up 2 units and right 1, and instead of opening to the right, as we would expect, it opens to the left. So this is my inverse function. The domain of my inverse is that my x values are less than or equal to 1, which was specified in the problem, but negative infinity to 1. The range is that my y values are from 2 inclusive to positive infinity. Switching both of those, x is now going to be from 2 to infinity in the domain of my inverse, and y is going to be from negative infinity to 1 in the range of my inverse. Finding the inverse, we replace f of x with y. We interchange x and y. We switch x and y. And then we isolate, solve for y. So I've got x minus 2 is the square root of 1 minus y. I'll square both sides. X minus 2 quantity squared equals 1 minus y. I'll subtract 1 from both sides of the equation. X minus 2 quantity squared minus 1 is negative y. And then I will divide by negative 1 or multiply by negative 1 on both sides of the equation. And I have negative x minus 2, and that's the quantity x minus 2 squared minus 1 equals y. So f inverse of x, my inverse function, is negative x minus 2 squared plus 1, because when I divide it by that negative, we need to make sure it was distributed across the page. So this is the graph of a parabola. We end up with the graph of a parabola. Thinking about transformations, reflected down across the x-axis is what that negative does. We're going to shift right 2 units and up 1 unit. So my graph here, my inverse graph, it is a parabola opening down, again shifted right 2 units and up 1. And so you're going to want to draw both the left and right half of this curve, because when we look at the function we have down at the bottom there, it's a parabola. But what you want to make sure and note is that we have a domain restriction. So looking at this right here, we said that x is only going to be to the right of 2, from 2 to positive infinity. So we're not having the left side of the parabola. It's only this right side. And of course, if I drew that back in there, it would not be a reflection over the identity. So this is the graph of my function that was given and the inverse. And I have one more problem that we're going to do in this section. We're not going to graph the function, but we're dealing with a rational function. We're going to find the inverse. So rational function, we have to think about the domain, and when we're considering domain, we need to remember that denominators can't be 0. So for the domain of f of x, we know that x cannot equal 5, because 5 would create a problem in my denominator. So negative infinity to 5 union 5 to positive infinity. And then the range, I'm going to need to leave out anywhere there's a horizontal asymptote, right? So there's going to be a horizontal asymptote. Since the degree of the numerator matches the degree of the denominator, we're going to use those leading coefficients, and we're going to have a horizontal asymptote at y equals 2 over 1, or y equals 2. So in this case, y cannot be 2, and my range is negative infinity to 2 union 2 to positive infinity. And I encourage you to, pull this up, plug it in your calculator, make sure you know what it looks like. But it does have a horizontal asymptote at y equal 2 and a vertical asymptote at x equals 5. So same type of problem. Again, we're going to find our domain and range, and we're going to switch those values. So the domain of the inverse is negative infinity to 2 union 2 to positive infinity. And the range of the inverse is negative infinity to 5 union 5 to positive infinity. So the last thing we're going to do in this video is we're going to find the inverse function. We always do it the same way. We replace f of x with y. I've got y equals 2x plus 1 over x minus 5. Then we're going to interchange our x and y values. So x equals 2y plus 1 over y minus 5. So this is where students get really stumped because it's hard to discern how we're supposed to isolate y, especially because we have two y values in this problem. So what we want to keep in mind is that x on the left is over an invisible 1. And what we can do is we'll cross multiply. So I have x times y minus 5 equals 2y plus 1. So I've cross multiplied. I've got it all on one line. And then I'm going to distribute. I'm going to take that x and multiply by y minus 5. I'm going to stretch that through there. And that's what students have a hard time seeing because you're saying, well, I want to isolate y. And if I multiply x by it, that just seems like really counterintuitive. So people get stuck here. But if we distribute it, then we can collect and factor GCF later. So what this leaves me with is xy minus 5x equals 2y plus 1. So now that I have two terms with y, I'm going to get them on the same side. And I'm going to pull that 5x over to the side where there are no y's. So here I have xy minus 2y equals 1 plus 5x. And it really doesn't matter how you like it, but I actually prefer writing 5x plus 1. All right, so if you notice now, on the left side, both of my terms have a y, and I can factor that GCF out. So I have y, and that leaves me with x minus 2 equals 5x plus 1. And now, if I divide, I can isolate that y value. So y equals 5x minus 1 over x minus 2. And cleaning up our final notation here, f negative 1, f inverse of x equals 5x minus 1 over x minus 2. And we're all done. So that is the inverse function. And if you note, thinking about your asymptotes, this function we're looking at here is going to have a vertical asymptote at x equals 2, which coincides with what we were looking at up above for our domain. And our horizontal asymptote is going to occur at 5 over 1, which is corresponding with the range. All right?